Welcome to the Metabolic Classroom. I'm Ben Bikman, a biomedical scientist and professor of cell biology. And this is the podcast where we explore the fascinating science of metabolic health and how it affects our everyday lives. I call it a podcast, but of course, as you may know by now, I think of it more as a lecture. Thanks for letting me be your guest professor. Before we dive in, just as a matter of business, I'm excited to share that I've launched benbikman.com. Of course, once again, as you know by now, Bikman is spelled B-I-K-M-A-N, no C. benbikman.com. That's going to be your new hub for all of my content. At benbikman.com, you can subscribe. You can become a member of the community at two levels, an insider or a pro insider. As a subscriber at either of these levels, you'll gain access to the show notes, including the citations that I always reference in these lectures, in addition to some bonus podcast content, especially at the pro insider level. And then you'll also get some early access to lectures that I'll be recording and sharing through the website, and some additional perks to help deepen your understanding of metabolic health. Please visit the site benbikman.com to learn more, and I can't wait to connect with you there. All right, let's get started on today's lecture. Today, we're diving into the effects of a ketogenic diet on thyroid function. This topic often stirs some concern. Some claim that lower thyroid hormone levels observed on a ketogenic diet indicate thyroid dysfunction, but is that the whole story? We need to understand the reason why there might be changes in thyroid levels before we make any conclusions as to the health of the thyroid gland, because perhaps the change in thyroid level is a reflection of thyroid resistance or changes in thyroid resistance. Perhaps it's an effect of a change in glucose metabolism and a handful of other potential reasons. So in the lecture today, we'll discuss how thyroid hormones work. So that'll be a bit of a fundamentals in physiology. We'll explore the evidence from studies on ketogenic diets. We will explore the concept of thyroid resistance as well as thyroid hormones' role in glucose metabolism, and more. All right. Now, one of the topics I love to discuss is physiology. That's one of the classes I teach as a professor. So humor me for a moment while we take just a few minutes to establish the basics. I think you might appreciate just some deeper understanding of thyroid gland and hormone regulation. To understand how a ketogenic diet impacts the thyroid, and in order for you to be able to put claims in context, we do need to start with some of the basics here. The thyroid gland is part of a system called the hypothalamic-pituitary-thyroid axis. Now, you'll notice that I was deliberately kind of acting this out by counting down. Hypothalamus, pituitary thyroid axis. This is one of the ways we teach this axis regulation. All of these are three parts of this intricate pathway, or what I'm referring to as an axis, that decides how much we need of thyroid hormone. It's essentially a way of fine-tuning the thyroid gland production of thyroid hormone. It's kind of the thermostat, if you will. And even the thermostat is a perfect example of a concept called negative feedback. If you think about the thermostat, you set the thermostat to a particular temperature. It's winter here where I am in Utah, so we need the thermostat to help warm the home. So let's say we set it at 69 degrees. And at 69 degrees, if the temperature starts to drop, the thermostat will sense that. The response will be to kick on the furnace. And then the central heating turns on within the home, which brings the temperature back up to 69. And then it's turned itself off. That's negative feedback. So within all of this is the control center, the effector, the sensor. These are all components within the thermostat. All of those components are, in another way, reflected within this axis of the hypothalamus at this what's called a tertiary level, the third tertiary level, feeding a signal to the pituitary, which is the secondary level, which in turn is feeding a signal down to the thyroid gland itself, the primary level. So to say all of that another way, the signal starts in the brain. The hypothalamus produces thyrotropin releasing hormone. This is just abbreviated as TRH. This is the tertiary level of regulation. This signal tells the pituitary gland, rather, not down to here yet, one little step down from hypothalamus to pituitary, to in turn release a hormone called thyroid stimulating hormone, or TSH. And TSH is a hormone that is always measured in the blood if you are looking at some markers of thyroid function. So TSH is going to be a commonly measured marker that if you've ever had a blood test that's measured thyroid hormone, that's going to be on there. Now, TRH isn't, because it is released in such low levels and only moves, millimeters in distance, and it doesn't flow into all of this systemic circulation of the body. So if you were to take a blood sample from a vein in your arm, you're not going to get any TRH because it's not making it that far. In contrast, TSH from that secondary level of the pituitary does have to migrate down to the thyroid gland, and to do so it spills into the blood. And so you can measure TSH in the blood. And so that brings us to the next step. So TSH from the pituitary gland is the secondary level, and then it travels to the thyroid gland, signaling to the thyroid gland to produce thyroxine, which is T4, and a smaller amount of the hormone triiodothyronine, 3 iodines, triiodothyronine, T3. In fact, that's the difference. T4 has 4 iodine molecules on it. T3 has only 3. And now this, at the level of the thyroid gland, is considered the primary level. And of these two thyroid hormones, T3 and T4, T3 is the active form of thyroid hormone. This is the one that is eliciting the actions that we typically think of when we think of thyroid hormone. It regulates metabolism and the rate at which every cell is doing its business. That's one way I often describe this, is that the general effect of thyroid hormone, T3 in particular, is that it will regulate the rate at which a cell is doing whatever that cell is doing. So when someone has hyperthyroidism, everything is happening more. And so they're hotter, they're twitchy, their nerves are actually working faster than they were before. They have a hard time calming down. Their heart is beating harder and faster. Everything is just sort of turned up a bit because thyroid hormone, if it's elevated, is elevating the rate at which everything's happening. It sort of sets the idle of the engine, if you will. Now, as I noted, thyroid gland produces a lot of T4 and a little bit of T3, and then a lot of that T4 will it almost acts as a reservoir of T3, because T4 will get converted to T3 throughout the body, most especially in the liver. The liver is the main site of pulling in this less active form, T4, and then spitting back out the active form, T3. And then back to this concept of negative feedback and the thermostat in this loop, or at this axis. When T3 levels especially are sufficient, when they're at a good level, they are flowing through the blood and going back to the hypothalamus and the pituitary gland, telling them, hey, I'm at a good level now. You can kind of turn down your signals. And this is very important, and it's a concept I'm going to touch on later to help put in perspective some of the findings that people will often claim support the idea that a ketogenic or a low-carb diet somehow damages the thyroid gland. We need to look at this entire axis in order to really appreciate what's going on. All right, so to sum this physiology primer up, if T3 is in a normal range, then TSH will be in a normal range. If T3 is low because of some primary problem with the thyroid gland, then you would think through this. In fact, this is the kind of question I ask my students in my physiology class. If T3 is down because of thyroid damage, then there's less to turn these upper components off. So now the hypothalamus and the pituitary gland are thinking, hey, there's not enough thyroid hormone coming from the thyroid gland. We need to kick it into action. And so what would you think would happen to TSH levels? Because remember, you can't measure TRH in the blood. So I won't even ask that one. What would happen to TSH? If the primary signal is down, if thyroid hormone is down, especially T3, What is the pituitary going to try to do to kick it into action? It's going to release more TSH. So TSH would be high. This is very important to keep in mind, to understand and to remember. Again, if the thyroid gland is struggling to produce T3, then TSH would be higher. However, if the thyroid gland is producing a proper amount of T3, whatever that amount may be for the given body, then TSH would sense, hey, everything's normal. There's no reason to react and to try to turn anything up or down. We're just going to stay in our normal level because T3 is at its normal level based on what our needs are. That's important to note. All right. Now let's get into some of the studies that people will claim support the idea that a low-carb or ketogenic diet somehow damages the thyroid gland. One particular study was published in the journal PLOS ONE. PLOS is an acronym, PLOS, PLOS ONE, they examined how a ketogenic diet affects thyroid hormones. Now, as a reminder, for you to get the citations and all the show notes, you have to be an insider. So go to benbikman.com and sign up and to join the community. I would love for you to do that, but that's something I'm happy to offer to you there. All right, so in the trial, they took 11 normal weight adults and they were put under 2 different diets, a high-carb, low-fat diet, and a low-carb ketogenic diet. Each diet, each patient or subject, we use the word subject when we're referring to a study. I'm not a clinician, so I don't use patients, I use subjects or participants. Each subject was put onto the diet for 3 weeks. And then they had 1 week off, and then they were moved on to just revert to their normal diet, and then they were put onto the other diet in a random order. Now, what did they find? This is one of the most oft-cited studies by people claiming that it damages thyroid because they found that T3 levels dropped significantly in this study on the ketogenic diet. T4 levels were unchanged, but TSH levels were also unchanged. Now, this is very important. I'm going to say that all one more time. T3 levels dropped a lot, so thyroid hormone went down, but TSH levels were in a totally normal range. Think through the concepts I just taught you. If this reduction in T3 was a sign or were a sign of thyroid gland damage, what would TSH levels have responded? I'm going to keep that open sort of as a hypothetical question, all right, because I think you've been able to think through that answer. All right, now, given that TSH, I'm kind of answering it now myself, given that TSH levels stayed normal, that is, I would say, absolute conclusive evidence that there was no thyroid damage. Because if the thyroid gland were somehow producing less thyroid hormone than the body needed, TSH would have gone up. That the hypothalamus and the pituitary would have sensed this as a problem and kicked more of their products manifested as elevated TSH up. That didn't happen. This then suggests that in the ketogenic diet, these bodies simply needed less T3. That is a very valid conclusion, a very rational conclusion. It's certainly the one I come to. I propose, and we'll spend a little time going over this, that there are 2 reasons for this. One is a change in thyroid sensitivity, and that concept involves a little bit of speculation because unfortunately there's no solid evidence that to address this. There's no studies that have asked that question. And then second, changes in glucose metabolism itself. All right, so the first of these concepts, let's discuss thyroid hormone resistance, a potential hidden factor that can explain some metabolic problems in people. All right, so thyroid hormone resistance, as the name suggests, is simply a condition where the tissues fail to respond adequately to thyroid hormone. There are ways, in fact, to measure thyroid hormone resistance, although there are no studies that have done this in the context of a ketogenic diet that I'm aware of, and I have sought diligently in trying to find them. I want you to be familiar with these 2 tests because perhaps you can measure them on your own, looking at your own blood tests. I actually don't love these 2 tests, and perhaps I need to help create a new one. And I'll explain why after. But these are the 2 tests that are used. One is called the thyrotroph thyroxine resistance index, abbreviated as TT4RI. This index assesses how the pituitary gland responds to free thyroxine, and thyroxine is T4. It's calculated by looking at TSH multiplied by the amount of free T4, and then the number, the higher value, the higher that number is, the more it suggests a reduced sensitivity to thyroid hormone. Then the other one is the thyroid stimulating hormone resistance index, or TSHRI. It's essentially the same. It's just a slightly different variable, but it's using the exact, or a slightly different formula, but it's using the exact same two metrics, namely T4 and TSH. And it's calculated by TSH divided by free T4. And the higher the number, the greater the thyroid hormone resistance. Now, again, as I noted, while I'm going to cite some studies that just show you that thyroid resistance is a real phenomenon, I'm going to do that in just a moment. Unfortunately, there are no studies that have used these metrics to measure thyroid sensitivity in the context of a ketogenic diet. So there's no study that looked at overweight, unhealthy, metabolically unhealthy individuals with thyroid resistance, and I'm going to cite some studies in a moment that do show that. Wouldn't it be great if they'd taken those people, put them on a ketogenic diet, and then measured those same outcomes? That's never been done. That's why I noted at the outset of this little segment that this involves some speculation on my part. All right. Now, what is there? Is thyroid hormone resistance even a thing? You might not have even ever heard of that concept, but it is a thing. As I just noted, there are, in fact, clinical tests that people will use. And there are multiple studies that show that this is a real phenomenon. Now, I just remembered a moment ago, I mentioned some of what I don't love about those tests. I don't love that they use T4. Remember, T4 is not the active form of thyroid hormone. Thyroid hormone in its active form is T3. I wish that there were some formula that used T3 instead of T4. Again, as I noted, perhaps my lab needs to be among those that help figure that out. All right. So some evidence of thyroid resistance in metabolic disorders or people with metabolic syndrome. There are several studies that have explored thyroid hormone resistance, including these measurements I just mentioned, in the context of obesity and metabolic syndrome. Okay, the first is a paper that was published in a very good journal, the Journal of Clinical Endocrinology and Metabolism, and they found that individuals with obesity often exhibited elevated TSH with elevated levels of T3 and T4. So this pattern does suggest, and you could cite those metrics I mentioned earlier, those formula, that despite sufficient thyroid hormone production, in fact, it was elevated, the tissues may be resistant. And the study concluded that thyroid hormone resistance is a significant factor linking obesity to impaired metabolic health. Another paper was published in Diabetes Care, another very good journal, highly cited, high impact factor. This research linked higher thyroid hormone resistance indices, these two metrics I mentioned, for example, to obesity, metabolic syndrome, and type 2 diabetes. And their findings suggest that impaired sensitivity to thyroid hormone could contribute to energy imbalances and metabolic dysfunction. I have previously spoken about the connection between thyroid hormone and insulin receptors, particularly on fat cells. I don't want to take the time to revisit that now, although now that I'm mentioning it, I can't help but want to talk about it a little bit. We'll see how I feel in a moment, whether I revisit that idea. But I have before. You can look through some of the previous Metabolic Classroom episodes. And in fact, for the sake of time, I won't. But there are direct effects of thyroid hormone on insulin receptor expression on fat cells, which is a direct regulation then of how thyroid hormone can, through insulin receptor, impact the growing and the shrinking of fat cells. Briefly, very, very briefly, when thyroid hormone levels are down, insulin receptor expression on fat cells goes up. So that means the fat cell is responding more and more to insulin. And what does insulin tell a fat cell to do? It tells it to grow. In contrast, when thyroid hormone levels are elevated, insulin receptor expression on the fat cell goes down, meaning the fat cell is less responsive to any given amount of insulin, and thus it's going to be more inclined to shrink. Now, there's a third study that was published in the journal Obesity Surgery, once again finding similar findings that reporting that the individuals with higher thyroid resistance indices, these metrics I mentioned earlier, had a greater prevalence of being overweight and obese. So the researchers noted that metabolic disorders mediated the relationship, suggesting that thyroid hormone resistance is both a symptom and a driver of metabolic dysfunction. Okay, so that just helps establish the concept that thyroid resistance is real. Now let's bring this all back to the point, which is, how does a ketogenic diet affect thyroid function and thyroid levels? What does it mean for the ketogenic diet? If thyroid hormone resistance is common in metabolic disorders, improvements in metabolic health, like those seen on a ketogenic diet, may enhance thyroid sensitivity. This could explain why lower T3 levels on a ketogenic diet are not a problem. Again, if there were a problem, we would see an elevated TSH. We do not see that. TSH is normal. That suggests that as far as the upper levels of regulation are concerned, everything is fine. Here's another layer of relevance. T3 is heavily involved in glucose metabolism. It upregulates glucose transporters like the most abundant GLUT4, glucose transporter 4, and it enhances insulin's ability to stimulate glucose uptake. On a ketogenic diet where glucose intake is minimized, we're eating fewer carbs, so there's less converting into blood glucose, the body's demand for T3 may simply be lower. This isn't a sign of dysfunction. It's an example of the body adapting to a new metabolic state. Now, let me talk about that, because I think it's the second pillar of our understanding of why thyroid hormone levels may be coming down on a ketogenic diet. The first was that it's likely a sign of improved thyroid sensitivity. If thyroid hormone is working better, we simply need less. And far from it being a sign of thyroid damage, if it were, then TSH would be elevated. It is not, suggesting that there's no crisis. Everything's fine. We just need less of it. Now, because it's working better, there's improved thyroid sensitivity. This second pillar then, the second part of this understanding, is this concept of glucose metabolism, where when we are consuming less glucose, we need to clear less glucose from the blood. And perhaps, once again, this is another reason why thyroid hormone goes down. When we talk about metabolism, thyroid hormone is often considered one of the primary conductors of this multi-piece orchestra. Among thyroid hormone's many roles, one of its roles is regulating glucose transport in response and insulin signaling, both of which are central to maintaining energy balance, especially in the context of appropriate glucose metabolism. All right, now let's break this down a little bit. First, thyroid hormone, particularly the active form T3, directly impacts glucose transport into cells. T3 enhances the expression of glucose transporter proteins like GLUT4. And GLUT4 is the main insulin responsive glucose transporter, and it is found in the biggest tissues of the body, skeletal muscle and fat tissue. So by mass, those tend to be the biggest tissues on the human body, and GLUT4 is what abounds in them. And GLUT4, as I noted, is an insulin-sensitive transporter, meaning it facilitates glucose uptake into tissues in response to insulin. By regulating GLUT4, T3 ensures that glucose can efficiently enter the cells, reducing blood glucose more easily, allowing the glucose to be burned for energy or stored for later use in the form of fat or glycogen. However, the relationship between thyroid hormone and insulin signaling is, in fact, a double-edged sword. As happens so often in the body, there can be too much of a good thing. While normal levels of T3 can support glucose transport and insulin sensitivity, if thyroid hormone is excessively on, like a case of chronic hyperthyroidism, This would be something like Graves' disease, for example. That can lead to insulin resistance. This occurs because the chronically elevated thyroid hormone starts to increase so much lipolysis that there's so much free fatty acids that now you actually are coming to this idea of the Randle cycle, or the glucose-free fatty acid cycle. But of course, on the flip side, hypothyroidism can impair glucose uptake by reducing GLUT4 expression. So there's simply not enough GLUT4, these doors that open up on the cells of muscle and fat, most especially, allowing the glucose to come in. All right, now let me just kind of state all of that again. What to me seems likely is that with less carbohydrate consumption, there's less of a need to stimulate glucose uptake into tissues in the body, like muscle and fat. In the ketogenic diet, those tissues are more reliant on fat for fuel or ketones for fuel, and they are thus less reliant on glucose. In other words, with greater carb consumption comes a greater need for assistance to clear that glucose from the blood. And thyroid hormone can help with this. But of course, as carbohydrate consumption drops, blood glucose isn't chronically elevated. The body does not need any extra help to clear the glucose. And thus, one of thyroid hormone's effects is now unnecessary, and thus no surprise that thyroid hormone levels may go down. Now, as a final thought on this lecture, let's compare this thyroid regulation to the pancreas and insulin regulation. Because I don't know why a person can't look at a study that shows low thyroid hormone levels and why conclude that's a problem, and yet look at another study that shows lower insulin levels and conclude that's a good thing. Now, let me elaborate. A hallmark of improved insulin sensitivity is that the body requires less insulin to regulate blood sugar levels effectively. When insulin sensitivity improves, the pancreas doesn't need to work as hard to secrete high levels of insulin. The fasting insulin levels naturally decrease. Insulin is simply working better. So this is not evidence of pancreas damage or dysfunction. Rather, it's a clear sign that the body is functioning more efficiently and responding to the insulin that is being produced. So it needs less insulin because the insulin is working better. And because there's less of this constant spiking of glucose, you simply don't need it as often. Drawing a parallel then to thyroid health, I submit a similar logic applies. When we see lower levels of T3 in certain contexts, such as during a dietary change like a ketogenic diet, why do we conclude that T3 levels going down is a problem? So instead of interpreting reduced T3 levels as a sign of thyroid dysfunction or damage, I believe it is more reasonable to consider this is simply a reflection of improved thyroid hormone sensitivity. Just as lower levels signify better insulin action when insulin levels come down and just simply less need, lower T3 levels may simply indicate that the body is using thyroid hormones more effectively, requiring less of the active hormone to maintain metabolic function. In this light, lower T3 is not necessarily pathological, but simply a physiological response to a healthy, indeed a healthier metabolic state, suggesting improved metabolic efficiency, at least in response to thyroid hormone. So what does all of this mean for you? Lower T3 is not automatically bad. If you're on a ketogenic diet and your blood test reveals a reduction in T3, it does not necessarily indicate harm. I'm not your clinician, of course, just your friendly neighborhood scientist. But if TSH is normal and you don't have any signs or symptoms of hypothyroidism, like weight gain, or you're cold, or you're lethargic and you're slow in your thinking and actions, then your thyroid is likely simply adapting to improved thyroid sensitivity and reduced glucose demand. Your body doesn't need the assistance of thyroid hormone to help clear these chronic elevations in blood glucose. All right, so to wrap it all up, a ketogenic diet may lead to lower T3 levels. There are studies that show this. There are also studies to show no difference in thyroid levels, but regardless, it does not suggest, I don't believe, that there's harm. It may simply reflect improved thyroid sensitivity and reduced metabolic demand for glucose clearance. Combined with evidence of thyroid hormone resistance in obesity and metabolic disorders, these findings do highlight the adaptability of the thyroid in response to dietary changes. I hope all of this has helped you gain a deeper appreciation of the majesty and miracle of the human body, and perhaps even give some direct insight into some things you've been thinking about, or some things you may have even noticed in your own lab tests or clinical outcomes that have changed. Thanks for joining me on the Metabolic Classroom today. Until next time, more knowledge, better health.